Assalamualaikum warahmatullahi wabarakatuh. So today we would like to present about OC model and TCP/IP model in real world context. And we are from Informatics A. And my name is Maysa Angelina Ridwan with study number 038.
My name is Nisrina Kholilah and three last digit number ID is 135.
My name is Sekar Ayu Novisca and last three digit number is 159.
So this is our presentation and agenda, which is the first one is introduction to OC model, and then the second is OC layers functions, and the third one is encapsulation and decapsulation, and fourth TCP/IP model, and fifth about comparison OC versus TCP/IP, and then the sixth one is real world case study, which is we would like to use example is YouTube streaming, and then the seven, which is the last, is conclusions. And the first one, we would like to talk about OSI model overview. So, the OSI or Open System Interconnection Model is a conceptual framework used to explain how data is transmitted between devices and a network. So, it consists of seven layers, and each layer has its own specific function and responsibility. And then they have a PDO, and of course, each layer has a different PDO except for layer 5 to layer 7. So, by dividing network communication into layers, it becomes easier to understand how data travels and easier to identify problems when they occur. Let's start with the top three layers of the OC model. So, the first one is the application layer is the layer that directly interact with user. Whenever we open applications such as Instagram, YouTube, or web browser, protocols like HTTP and HTTPS are used at this layer. Also, it uses FTP and SMTP as the protocols. And next is the presentation layer. This layer is responsible for data formatting, encryptions, and decryptions. For example, WhatsApp uses encryptions to ensure that messages remain secure during transmissions. And then the third layer is session layer, which is this is actually layer 5. So, its function is to establish, manage, and terminate communication sessions between devices. For example, when we log into a Google account, the session remains active even when we open multiple tabs. So, we don't have to log in at every single tabs that we opened. And next, the core layer that data delivery happens. So moving on the middle layer of OSI model, the transport layer is responsible for end-to-end communication and ensuring that data is delivered correctly. So two common protocols used here are TCP and UDP, which is the characteristic of TCP is reliable, and the example is Netflix, and UDP is fast, and the example is WhatsApp calls. So, TCP provides reliable communication by checking whether all data has arrived correctly. This is commonly used for web browsing, file download, and video streaming. And then the UDP, on the other hand, focused on speed rather than reliability, making it suitable for real-time applications such as online gaming or voice or maybe video calls. And then the common part is HTTP, which is commonly used and 0, and HTTPS, which is commonly used for 3, and then the last one is SSH, which is commonly used 2 and 2. And then the next layer is network layer. This layer uses IP addresses to determine the best route for data to travel across networks. Routers operate at this layer and help forward packets toward their destinations. So, commonly used protocols as IP or ICMP, and the primary device is router. So, and then next we have bottom layer, the medium. And the first one is data link. So, data link layer is responsible for communication within a local network. It uses MAC addresses to identify devices and ensures that data frames are delivered correctly between connected devices. Network switches operate at this layer, and then uh, commonly uses Ethernet and MAC addresses, and the primary device is switch. So the protocols, maybe we can use Ethernet IEEE 802.3, and then we can use Wi-Fi IEEE 802.11. And finally, the physical layer is the lowest layer of the OSI model. It is responsible for transmitting raw bits through physical media such as Ethernet cables, fiber optic cables, or wireless signal like Wi-Fi. And next slide is about network device hierarchy. So, different networking devices operate at different layers of the OSI model. A hub or repeater works at the physical layer because it simply forwards signals without examining the data, and then a switch or the bridge works at the data link layer because it uses MAC addresses to forward frames to the correct device. And then a router works at the network layer because it uses IP addresses to route packets between different networks. And finally, gateway can operate across multiple higher layers and are often to use to connect different systems or protocol. And before data can be transmitted through a network, it must go through a process called encapsulation. During encapsulation, data moves from the application layer down to the physical layer. As the data passes through each layer, additional information called headers is added to help with delivery and communication. Once data reaches the destination device, the reverse process occurs. This process is called decapsulation. During decapsulation, the data moves from the physical layer back up to the application layer, and each layer removes the information that was added earlier. So, this process allows the receiving device to reconstruct and understand the original message correctly. And next, we move to Sekar.
Now I will explain the TCP/IP model. Unlike the OC model, TCP/IP has only four layers: is application layer, transport layer, internet layer, and network access layer. Next. Okay. Each layer has different protocol. HTTP, DNS, SMTP, and HTTPS each belongs to the application layer. TCP and UDP belongs to the transport layer. IP and ICMP works at the internet layer, while Ethernet and Wi-Fi operate in the network access layer. Some common part numbers are HTTP S is 443, HTTP is 80, HHH is 22, and SMTP is 25. Okay, next. And next is anatomy of an HTTP request. So, for example, when we open YouTube, the browser first sends a request to a DNS server, such as Google's public DNS at 8888. And to translate the domain name into an IP address, after obtaining the IP address, a TCP connection is established through a process called the TCP handshake. Then, an HTTPS request is sent to the server. The packets are routed through the network and transmit physically through Wi-Fi or Ethernet. The server sends back the request data and the web page is displayed to the user. Okay, next. Now let's compare the OSI model and TCP/IP model. The OSI model consists of 7 layers and mainly serves as theoretical reference model. In contrast, the TCP/IP model has 4 layers and is used as the practical standard for the Internet. In the TCP/IP model, the application layer combines the functions of the application, presentation, and session layers from the OSI model. The transport layer corresponds to the transport layer in OSI. The internet layer corresponds to the network layer, and the network access layer combines the data link and physical layer. So, why TCP/IP is dominant? TCP/IP is more widely used because it has a simpler architecture, is capable, and is supported by almost all devices and operating system. Okay, next we move to Rina.
Okay, for our case study, we choose YouTube streaming, applying network models to video streaming. Next. Many networking technologies work together to provide smooth video playback. For the example, streaming 4K video requires massive coordination across networking layers. DNS find the closest edge servers, HTTPS ensures secure transmissions, TCP manages data flow and loss, CDN or content delivery network reduce latency. Next. OSI analysis of YouTube. Using the OSI model, YouTube starts with HTTP and HTTPS at the application layer. Encryption is handled by TLS, TCP ensures reliable transmission, IP perform routing, and Wi-Fi signals carry the data physically. Next. TCP/IP implementation. In the TCP/IP model, YouTube mainly uses HTTPS, TCP, IP, and Wi-Fi or Ethernet. Content delivery networks or CDNs bring data closer to the users and buffering helps maintain smooth playback. Next. So why YouTube streams smoothly? First, the server DNS finds the local CDN node. Latency, CDN places data closer to the users. Reliability, TCP ensures no lost segments. Interruption-free, buffering stores data locally first. In conclusion, the OSI model provides a conceptual framework, while TCP/IP is the practical model used on in the Internet. Understanding both models allows us to better analyze technologies such as YouTube, Netflix, and online communication system. Next. And there are several references we use. First is Frozen, Data Communication Networking 5th edition, Tenenbaum and Witherall, Computer Network 5th edition, Cross and Ross Computer Networking, a top-down approach 7th edition, Cisco Networking Academy, Networking Essential and CCNA curriculum, Cloudflare Learning Center, Network Fundamentals and Streaming Analysis. And that's all from us. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.